ESA has released a new map showing the first light of the universe that challenges some of the fundamental principles of the Big Bang theory. This latest cosmic microwave background map from Planck, ESA's mission to investigate the origins of the universe, questions some of the concepts behind the basic theory of the expansion of the universe, commonly known as inflationary theory.
We see these strange patterns that are not expected, in inflationary theory, the simplest inflationary theories. It may be that we've been fooled, that inflation didn't happen, and it's perfectly possible that there was some phase of the universe before the Big Bang actually happened, where you can track the history of the universe to a pre-Big Bang period.
In constant rotation, Planck scans the entire sky at millimetre and sub-millimetre wavelengths. Visible light telescopes see little more than the tapestry of galaxies around us, but by making measurements at wavelengths between the infrared and radio, Planck is able to work back in time and show us the history of the universe from the first light ever produced. These fossil radiations resulting from the Big Bang are called the cosmic microwave background.
Cosmic microwave background gives us a picture of the state of the universe 300,000 years after the Big Bang. And using a model to extrapolate, we can then move backwards in time to even earlier times than when that light was emitted. And we can infer what the phenomena around the time of the Big Bang were.
What's surprising in Planck's latest findings, and is inconsistent with pervading theories, is the presence of unexpected large-scale anomalies in the sky, including a large cold region, stronger fluctuations in one half of the sky than the other, and less light signal than expected across the entire sky.
When you look only at the large features on this map, you find that our best fitting model, our best theory, has a problem fitting the data.
Planck, launched in 2009 by Ariane 5, is the third mission to study the cosmic microwave background to date. While these unusual features in the sky were hinted at in the two previous US missions, COBE and WMAP, Planck's ability to measure the tiniest of fluctuations in the cosmic microwave background has made these so-called anomalies impossible to ignore.
Because of these features that we're finding in the sky, people really are in a situation now where they cannot ignore them anymore. There have been hints of these things in the past, and they have been able to ignore them, but not anymore, because we've established them as facts.
With its extreme accuracy, Planck was expected to revolutionize our understanding of the birth, evolution, and ultimate fate of our universe. It's this very accuracy that may now make it necessary for scientists to rethink some of the underlying theories of how the universe began and how it's evolving.
Scientists believe 14 billion years ago, the universe burst into existence, and the universe has been expanding ever since. Well, it's quite the theory, but proof? Astronomers in the U.S. say they now have evidence of what happened right after the Big Bang. It's a lot to wrap your head around, so let's bring in Bob McDonald to explain what scientists are so excited about. Bob, tell us.
Well, Peter, this is pretty esoteric stuff, but it has to do with a point. A few trillionths of a second after the universe was born, it popped up. It got really fast expansion. They call it inflation. And this has been a theory around for a long time, but they haven't actually seen good evidence of it. So if you look out beyond the stars, beyond the galaxies, as far as you possibly can in space, you will see a background glow. And my first graphic shows you this. This is what the cosmic background radiation looks like. And this was mapped a number of years ago. I know it looks like an Easter egg, but that is the remnant of the Big Bang. So recently they've been studying one part of this in great detail, and they saw a pattern. And my next graphic shows you this kind of swirly pattern where the radiation has been, I don't know, kind of bent and stretched. And the only way that that can happen is with gravity waves. Now, gravity waves have been a great theory for a long time, but nobody's ever seen direct evidence of them. And if that's what this is, that means that their theories are correct. So in other words, The scientists do all these great, mathematical formulas to describe the universe, but until we see it in nature, we don't know if they're true. This means that they probably are on the right course.
Well, what's next? Where do they take this research?
Well, what they're hoping for now is that they can work gravity into all these other theories that they have about how the universe works and come up with one grand theory called the theory of everything, which pretty well includes the entire universe. So the theory of everything may come out of this, and who knows what's going to come out of that, Peter. This is all new physics, but at least we're on the right track, knowing that the universe is expanding as it should.
That's good to know. Thanks, Bob.